This is the video for the 7.4 to 7.7 study guide. Okay, here they give us the slope and a point, and the point is -2, -7. It's hard to see here. And they are asking us to put it in slope-intercept form, which is y equals mx plus b. Now there's two different ways you can do this. You can plug in x and y, and that would make, okay, sorry, went a little crazy there. So I'm going to plug in -7 for y. Your slope is 4, and then for x I'm going to plug in -2, and then I'm going to solve for b. So this gives me -7 equals -8 plus b. Add 8 to both sides, and b is equal to 1. So now that I have my b and my m, I can plug into y equals mx plus b. So you would just say y equals, your m is 4, x, and your b is 1. So y equals 4x plus 1. Now there's also another way to do it. And the other way to do it says you're going to take your slope, which is 4, and your point, which is -2, -7, and you plug into point-slope form. And the way that you do this is you do x1, y1. So you do y minus -7 is equal to, you know your slope is 4, x minus -2. Add a line, change a sign, add a line, change a sign. So you have y plus 7 is equal to 4x plus 8 when you distribute the 4. Then I'm going to subtract 7 from both sides, and you get y is equal to 4x minus plus 1. Either way, you get the same answer. Alrighty. Okay, this is extremely hard to see what it's actually saying. So I'm going to get rid of this 7 right here. There we go. Alright, let me rewrite the problem for you guys. It says 25 minus 10 minus the quantity 6 minus 8 plus 3 minus 5 cubed. Okay, so PEMDAS says you start with parentheses first. So I'm not going to touch anything until I get to the parentheses. 6 minus 8 is -2. Plus 3 minus 5 is -2. Now I'm not going to touch anything until I'm dealing with an exponent. So -2 cubed is -8. And notice here I just add a line, change the sign. So now I have 25 minus 10 plus 2 is 12. We're not going to say plus -8. We're going to say minus 8. 25 minus 12 is 13. And 13 minus 8 is 5. So for number 2, your answer is 5. Alright, now we're dealing with our radical rules. Remember, in order to solve a problem that's involving radicals, you have to get one of the radicals isolated and then square both sides. Whoops. So here I am going to square. I broke my iPad. Okay, I fixed it. Square both sides. So we have the square root of 3x squared equals 25. The square root and the square cancel, leaving you 3x equals 25. Divide both sides by 3, and you get x equals 25 over 3. And now we're going to plug this back in to make sure it works. We've got the square root of 3 times 25 over 3 is equal to 5. The 3's are going to cancel, because remember this is 3 over 1, and you've got this square root of 25 equals 5, which is a true statement, so x equals 25 over 3. Okay. Here we have the cube root of 4x plus 3 minus 2 equals 0. So I need to add 2 to both sides, because I need to isolate the radical. So I've got the cube root of 4x plus 3 is equal to 2. Then in order to get rid of the cube root, I'm going to cube both sides. Cube root and cube cancel, leaving you 4x plus 3 is equal to 8, because 2 cubed is 8. Then I'm going to subtract 3 from both sides, leaving you 4x is equal to 5. Divide both sides by 4, and you get x equals 5 over 4. Excuse me. So now we're going to plug back in to make sure that it works. We've got 4 times 5 over 4 plus 3 minus 2 equals 0. Put your 4 over 1. Your 4's cancel, leaving you the cube root of 5 plus 3 minus 2 is equal to 0. 5 plus 3 is 8. Cube root of 8 minus 2 equals 0. The cube root of 8 is 2. So 2 minus 2 is 0, and that is true. So x is equal to 5/4 is your answer. Okay, this one actually says the square root of 3x plus 1 equals 3 plus the square root of x minus 4. Okay, so we have our radical on the left isolated, so we can go ahead and square both sides. The square and the square root cancel, leaving you 3x plus 1 is equal to 3 plus the square root of x minus 4 and 3 plus the square root of x minus 4. So we're going to go ahead and FOIL. We get 9 plus 3 square root of x minus 4 plus 3 square root of x minus 4 plus the square root of x minus 4 squared. And then you've got 3x plus 1 is equal to 9. These are like terms. Plus 6 square root of x minus 4. And the square root and the square cancel, leaving you just plus x minus 4. Now, 9 minus 4 on the same side, sorry about that, give you a 5. Plus 6 square root of x minus 4 plus x. And now that we've gotten to this point, but we still have a radical, that means we need to go ahead and do our steps again, which means I need to isolate the radical. So I'm going to move everything away from it. So this is going to leave me 2x plus 1 equals 5 plus 6 square root of x minus 4. Then I'm going to subtract 5 from both sides, leaving me 2x minus 4 is equal to 6 square root of x minus 4. Now remember, this is where I told you, square both sides. Do not divide both sides by 6. When you square both sides, you get 2x minus 4 times 2x minus 4 is equal to 36 times x minus 4. And how that happens is it's 6 squared. It's 6 squared times x minus 4, square root of x minus 4 squared. So these cancel, and 6 squared is 36. So that's how you get 36 times x minus 4. So now we're going to go ahead and distribute. So we're going to have 4x squared minus 8x plus 16 is equal to 36x minus 144. The squared here should be a dead giveaway that I'm going to have to factor. So So after I clean this up a little bit, I'm going to move everything from the right side to the left so that I'm set equal to 0 so that I can factor. So I subtract 36 from both sides, which gives me 4x squared minus 52x plus 16 is equal to negative 144. Then I add 144 to both sides, leaving me 4x squared minus 52x plus 160 equals 0. First rule of factoring is factor out anything that all three terms have in common. They all have a 4 in common. So I get x squared minus 13x plus 40 is equal to 0. Divide both sides by 4, and you get x squared minus 13x plus 40 is equal to 0. So you're going to build your houses. Factors of 40 are 1 and 40, 2 and 20, 4 and 10, and 5 and 8. 5 and 8 are what's going to give me 13. So I have an x and an x. If your first sign is minus, you change your second sign, and your larger number always goes first. Then you're going to set each house equal to 0. And your answer is 5 and 8. Now remember, you have to check both answers. Now we checked both answers in class yesterday, so there's no need to plug it in, for me to plug it in today again. We know that both answers work, and so your answer is 5 and 8. Okay, this one says the square root of 6a minus 3 square root of 150a plus 6 square root of 216a. Oops. Okay, so square root of 6a we have to leave alone because we can't simplify that at all. And then I'm going to write minus 3 so I don't forget about it and do parentheses. So I've got the square root of 150. I know my parentheses is going to have an a in it because of this a right here. So 150 can be broken down to 50 and 3, and then 50 to 5 and 10, and then 10 to 5 and 2. So I know I can bring a 5 out front, and then inside I'm going to leave 3 times 2, which is 6. And then I've got plus 6. Now let's do the square root of 216. I know that my root's going to have an a in it because of this a right here. So 216 is 108 times 2. 108 is 54 times 2. 54 is 6 times 9. 6 is 3 times 2. And 9 is 3 times 3. So I can bring a 3 out front and a 2 out front, which means I can bring a 6 out front. And I'm left with 3 times 2, which is 6, which is in the parentheses under the radical. So I have the square root of 6a. Negative 3 times 5 is negative 15. So minus 15 square root of 6a. Plus 6 times 6 is 36 square root of 6a. So because all of my indexes and my radicands are all the same, I can go ahead and add my coefficients. So don't forget, there's a 1 out in front here. So 1 minus 15 is negative 14. Negative 14 plus 36 is 22. And then you just tack your square root of 6a onto the back of it. Okay. On this one we have the square root of 128 plus 9 square root of 98 plus 4 square root of 32. So the first thing I'm going to do is simplify 128. So 128 is 64 times 2, and 64 is 8 times 8. I can stop there because now I know I can bring an 8 out front, leaving just a square root of 2 inside. Plus 9 times, now we're going to break down the square root of 98. 98 is 14, 14 and 7, and 14 is 7 and 2. So I can bring a 7 out front and have a square root of 2 left. plus 4 times, we're going to break down 32. 32 is 4 times 8. 4 is 2 times 2. 8 is 4 times 2. And 4 is 2 times 2. So I can bring out 1, 2, 2 2's, so that's a 4. And I'm left with the square root of 2. Okay. So that's going to give me 8 square root of 2 plus 9 times 7 is 63 square root of 2 plus 4 times 4 is 16 square root of 2. So when I add them all together, because they have the same indexes and the same radicands, you get 8 plus 63 is 71. 71 plus 16 is 87 square root of 2. And that is your answer. Okay, all you have to do here is distribute. So you get 7 times 63 is 441. So you get the square root of 441 plus the square root of 7 times 21 is 147. Now you need to see if you can simplify and add anything together. So the square root of 441 is 21. So I say 21 plus, and then let's break down 147. 147 is 21 times 7, and 21 is 7 times 3. So I can bring a 7 out front, and I'm left with the square root of 3. So my answer is 21 plus 7 square root of 3. Okay, here I have 8 square root of 19 plus 9 times 7 square root of 19 plus 6. So let's write our little plus there. Okay, so we're going to distribute 8 square root of 19 times both pieces of the second binomial. So 8 times 7 is 56. And then I do square root of 19 times the square root of 19 is the square root of 19 squared, because we know later on that's going to cancel. Plus 8 square root of 19 times 6. So you do 8 times 6 is 48. And then you just tack your square root of 19 onto that. Plus, now distribute the 9. 9 times 7 square root of 19, multiply the 9 and the 7 to get 63, and then square root of 19, plus 9 times 6 is 54. Here your square root and your square cancel, leaving you 56 times 19, plus same radicand, same index, so you can add the coefficients together. 48 and 63 is 111, square root of 19, plus 54. 56 times 19 is 1064, plus 111 square root of 19, plus 54. And now I can go ahead and combine 1064 and 54. And you get 1,118 plus 111 square root of 19. And okay, here they want us to rationalize the denominator. So when rationalizing a denominator and you have a monomial in the denominator, you just multiply by the denominator over the denominator. So in my numerator, you have the square root of 11 times the square root of 13, which is the square root of 143. And then in the bottom, you have the square root of 13 times the square root of 13, which is the square root of 169. Well, we know the square root of 169 is 13. We just have to see if we can simplify the square root of 143 at all. And it looks like we cannot. So our answer is just the square root of 143 over 13. Okay, now that we have a conjugate in our denominator, instead of multiplying by just the denominator, we're going to multiply by the conjugate of the denominator. So same as the denominator, but change the operation. On this one, make sure you're using parentheses or it's going to get very confusing. So we're going to distribute our numerator. So we'll get the square root of 9 minus the square root of 12 minus the square root of 12 plus the square root of 16 over, and remember the rule when you're multiplying conjugates, just multiply your first terms together to get square root of 9, and then multiply your second terms together to get negative square root of 16. So here the square root of 9 is 3, square root of 16 is 4, square root of 9 is 3, square root of 16 is 4. So we've got 3 minus, and here the square root of 12, negative square root of 12 minus square root of 12 is negative 2 square root of 12 plus 4 over 3 minus 4. So here we've got 3 plus 4 is 7 minus 2 square root of 12 over 3 minus 4 is negative 1. You never want to leave a negative in the denominator like that. So we're going to go ahead and take our negative and put it in the numerator, but that means I have to change all of my signs. This is the answer on the study guide. However, you should technically reduce the square root of 12, but you don't have to because the study guide stopped there. Okay, now I've got 2 over the cube root of 11. So I'm going to multiply by the cube root of 11 squared. In order to get a cube root to cancel, I need 11 of the, I need there to be 3 11s. So 3 radicans. So they started me with 1, and so I had to bring 2 more to the table in order to make it cancel. So what happens here is I get 2 times the cube root of 121 over the cube root of 11 cubed. Because I had 1 11 here and I did use 2 more here, that makes my cube root and my cube cancel, leaving me 2 cube root. Here I've got a triangle. My sides were 5 and 6, so it must have looked something like this. Okay, so I'm plugging into the Pythagorean theorem. A squared plus b squared equals c squared. So we have 5 squared plus 6 squared is equal to c squared. 5 squared is 25. 6 squared is 36. 25 and 36 is 61 is equal to c squared. So you square root both sides to get rid of the squared, and c is equal to the square root of 61. Next we have square root of negative 188. Anytime that you have a negative under an even index, you know that you're going to break it up the square root of negative 1 times the square root of 188. You know the square root of negative 1 is I, and then let's break down 188. 188 is 94 times 2. 94 is 47 and 2. And 47 actually can't go any further. So I can pull a 2 out front, and then I have to leave the square root of 47, and this is times I. So you're going to multiply your I and your 2, and you're going to get 2I square root of 47, and that is. And then this last one says negative square root of negative 236. So it's negative 1 times the square root of negative 1 times the square root of 236. So we'll leave negative 1 alone. Square root of negative 1 is I, and let's break 236 down. 236 is 2 times 118 118 is 2 times 59. And 59 can't actually go any further. So I'm going to take the 2 out front and leave the 59 inside. So I have negative 1 times I times 2 square root of 59. That gives me negative 2I square root of 59. And that, my friends, is your last problem on the study guide. Good luck on the test tomorrow.